Okay, in this tutorial, I'm going to talk you through how to interpret a kite graph, which you can see in front of you. But to start with, I'm also going to discuss what we call a long profile, and actually how these two particular types of graphs can be used together to interpret data. I'll also talk a little bit about the reasons you might wish to do this. So a long profile is a graph. It looks like a line graph that shows you how something changes across a distance. And in this case, it is the gradient of the land. Now, the example that you can see on the screen is a beach profile. And we're starting from the shoreline at 0, and we're working our way inland with distance. And as we start to move away from the sea, the height starts to increase. We're moving above sea level. And we can see, therefore, we've got a steeper gradient here. It then actually decreases. We've then got a second steeper gradient. Then there's a flat period of time, and then it starts to increase again, the gradient. So we can see how the shape of the land is changing as I move along. In this case, it would probably be a transect in which I gathered data. And I would have used some ranging poles and clinometers to gather the gradient at set distances as I move further away from the beach. And that would allow me to develop the long profile. Now, why would I do this? Well, normally, if you're going to do a long profile, you would then try to find out some other information to see if there is a relationship between the second thing that you've gathered. So it might be, for example, the number of types of a certain plant that appear, or it might be the type of land use that might appear along a distance, and see if there was any relationship between that and the long profile. So on a steeper slope, for example, are there certain types of things happening? And on a flatter slope like this one here, are there other things happening? So that's the purpose behind a long profile. And if I now show you a type of graph that works really well working alongside a long profile, it's the kite graph. Now it's named as a kite graph because it ends up looking a bit like kites. And it's almost like trying to show you how a percentage changes, but along a transect. So it contains some of the characteristics of a pie chart, but actually it's imagining the data in a very different way. So if I just go through this example to help you understand what you're looking at. So the x-axis of this particular graph is the distance along a transect. So for example, in the previous long profile that I was showing you a second ago, right here, this would be the actual shoreline where the sea is. And as I move inland, you can see the site numbers, I'm moving away from the sea. Now, it doesn't have to be the sea. It could be just moving along a distance. It doesn't actually, in theory, have to be even a straight line, although more often than not, it is a straight line distance that you've traveled. And what we can see is 3 different plant species. And we can see this one called sea sandwort. And what we can see is that it only appeared at site 1. And by the time you left site 1, it went down to 0%. Now, the way the graph is actually read is it's got a plus 50% and a minus 50% scale. That's the maximum. So if it goes all the way to 50 up here, then the reverse, the negative scale, would also go down to 50. And that would tell me that it was 100%. If I think of 50, add 50, I've got 100. So here I can see it's at 20%, and it's 20% here. So I can see that 40% of the beach at this site 1 was covered in sea sandwort. By site 2, which is this one here, there's nothing. If I compare it to marram grass, site 1, there's none. By the time I get to site 2, which is this one here, I can see 10 plus 10, which means it's 20%. And by the time I get to site 3, I can see that there's 20 plus 20, so I've got 40% of this thing called marram grass. Right, now, why use a kite graph? Because it shows you quite nicely the percentage changes in the amount of anything it is that you're measuring. In this case, it's different plants along a transect. So for example, I can see in this that around about site 3, there was an increase, but then it dropped away in site 3 and site 4. It then increased again after site 4, peaking at site 6, dropping a little again, and then disappearing at site 9 to a very low level. In site 9, 10, 11, there was a small amount of this grass, but then there was a sudden increase again at site 12. And then by the time I get to site 14, which is this site here, this type of species has completely disappeared and doesn't appear again at any point along my transect. So it allows me to look at the pattern of change in something as long as it's gathered as a percentage. And it's the pattern of change along a transect. If I take 3 of them and I line them on top of each other like I've done here, I can then compare. So I can see that sandwalk clearly only appears at the beginning. These 2 don't appear at all. I can see that rest harrow only appears at site 3 and doesn't appear before that, and then completely disappears after site 12. Compare that to marram. It starts to appear earlier than rest harrow, and it lasts longer as a species on my transect than rest harrow and sea sandwort. Now, if I then put my long profile at the top of that, this beach profile here, I could possibly see that there was no, this location here, there was no marram grass. Why? Because the gradient dropped. I could see that when it was really steep, there might not be anything of a certain species. So I start to be able to relate my gradient data, which I've presented on my long profile, to my kite graphs. There is below here in the main student booklet a very different way of imagining this. So we're looking at land uses that appear as you move away from the city center. So here we've got retail, and we can see that there's a huge amount of retail at site 1. We got to site 4, there was none. A tiny bit of retail appearing at site 7, disappeared again. In contrast, if I go down 1, we can see that housing, there was nothing between site 1 and 3, then increased dramatically to site 4, and then decreased again. This is a similar kite graph to the ones we're looking at above. It's just shown in a slightly different way. Okay. The downside of kite graphs, the one kind of criticism of kite graphs, is that they can be quite difficult to interpret to somebody that's not familiar with using these types of graphs in the first place. You also need your data gathered as a percentage at a range of locations, and of course your data has to be on a transect, gathered on a transect, in order for you to be able to create this. But it's very strong when comparing things to each other. So for example, comparing the different types of species on a beach transect, or comparing the different types of land use on an urban transect. Okay,